Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you. This tutorial is a follow-up or a continuation of the previous tutorials where we presented and eased ourselves into the code editor from the Google Earth engine. This tutorial focuses on one particular data set that was very prominent during the COVID pandemic. So remember, we can either open the code editor from the platform itself, the tab here, and then you have to copy and paste the code, or we can simply go to the data set and open the code editor from the data set. Now, the data set is the one I'm familiar with the data set, so I'm not going to go and use the standard option of going through the data sets itself. I'm simply going to go to the search function, type in the tag of the data set, press enter, and the engine will search for the data set. This is the one that I'm looking for, the near real-time carbon monoxide data set. So to open the data set, I'd simply just press left click on the heading itself, and we get to the familiar page that contains all the information related to this specific data set. So the data set is called the Sentinel. It's the satellite name is Sentinel, and we're looking for the real-time carbon monoxide data set. You see the data itself, the data set availability is multi-year. So this is not a singular image, but a number of images. Most probably either monthly, most probably monthly images, although we don't know. The data set provider, and then obviously the unique identifier of the data set. And remember, this is the identifier that we use in the code editor. Importantly, we're looking at the description. You can read through the description itself. There's some important information and content that's relevant. But the most important one is the band. Which band in this data set are we gonna use? The one that we're gonna use is the CO column number density, which basically is the molecules per square meter, ranging from a minimum of 297 molecules per square meter to a maximum of 4.64 molecules per square meter. The description is vertical integrated CO column density, and it will come clear if once we display it on a map what this actually means. Okay, so now that we familiarize ourselves with the data set, all the ins and outs of the data set, unique identifier, the band, the unit of measurements, etc., we can scroll to the bottom of this page, and there is our familiar code. Okay, remember, you can either copy and paste it into your code editor, or you simply click on the open code editor button, and it will take you straight through to the code editor. Okay, and here we are. We've got the code in the code editor, and let's start from the top again. Again, we have our image collection. Remember, image collection means there's a number of images within that data set. The unique identifier as per the site details. There's the unique identifier. It's exactly the same as that. Then remember, we select our data band set. Okay, in this case, the band that we are selecting is the CO column number per density, exactly the same as it's highlighted in this page. Remember, it must be exactly the same. And then importantly, remember in the previous ones where there was multi-images or image collection, if we don't specify the date of the image, it will take the first image in the collection. Okay, so that's important. If we don't specify a date, then the engine will generate and present the first image in that collection, whatever that image would be. Okay, so here we specify the date of the image. And the code is dot filter date. Remember date with a capital letter. And we uh, put down the starting date and the ending date. Remember, there's a beginning and an end, always the case. In this case, we're looking for the image um, from the 1st of the 6th month, 2019, till the 11th of the 6th month, 2019. So the image within that period we want to select. Okay, so just confirm it is a unique identifier of the data set, the band of the data set that we're interested, and the date of the image that we're interested. Now we can change all of these variables in terms of the date, so you can specify the period based on your interest. Okay, then we go into the familiar um, uh, visualization parameters of the image as we're going to display it. In this case, we don't present the codes, we present it in terms of the colors itself. So that's a different way of presenting the palette, but the option is up to you. We have a minimum of 0 and a maximum of 0.05 that we're going to present. Um, we're going to, let me just, the map center, let's put it before the layer. The map center, as per normal, is the location that the map will be centered and the zoom level. Again, don't want to go with a zoom level of 4. I want to go with a zoom level of 10. I want to center the map around my location. Again, I click on this little marker here. I click on my region of interest. I generate um, my coordinates. I copy my coordinates and I paste it into the map center. And there, it's now going to not center it around its original place. It's going to center it around the area, my region of interest, and I delete that. And as I said, I have zoomed it out. Now, interestingly here is in the map add layer code, it says collection dot mean open brackets. Now the collection refers to the variable that you've created. Remember, you've created a variable called collection, and that variable is an image from that data set, from that database, and filtered for that period of time. So you've created a variable now. Now, there might be multiple images in this duration, in this time frame. We don't know. So what we're telling the Earth Engine here is if there's more than one image in that period, then generate a mean image. So don't take the first one, don't take the second one, don't take the last one. Take the X number of images within that time frame and generate a mean image of those ones. So that's what we are doing here. So we're taking this variable, this collection, and we're generating one variable, and that variable is the mean on that specific period. If there's only one image, then that will be your mean image. If there's 2 or 3 or 4, it will take that images and generate the mean image. Okay. And interesting here, you can change the mean. You can change it to the medium image. You can change it to the sum image. You can change it to a count image. So you can change that statistic. We can play around with that as well. Then the bandwidth is the name of the color or your visualization parameters. That's the variable bandwidth. There's your visualization parameters, and there's your name that you allocate to this image. S5PCO. I'm just going to make it CO. I'm not going to bother with that. Okay, so let's run the code and see what happens. Okay, so first of all, it's going to center around my location. It's going to zoom into the area, so it's quite closely zoomed. And this would be a mean image of all the CO images within that time frame. Okay, so let's zoom out a bit. So I'm just going to scroll out because I see that the zoom level of 10 is a little bit too much for this specific image. So let's zoom out and display it in a worldwide map. Let's give it a couple of seconds for it to load. And remember, while I'm doing, I can play around with the transparency. I can play around with the transparency. Okay, so it gives you need because now you can connect features in the image with the satellite or with the maps. So you can identify places of specific interest. And you can see here that obviously the red here is the highest CO2 areas, and the black or the blue or the black is the lowest CO2 areas. So it's interesting to note that there's quite a significant red and yellow area here, sort of in the middle of Africa, and then there's two areas here which relates to China, if you put it there, China and South Korea, the India, China and South Korea, and then some area in a little bit of area in Northern America. Now remember, CO is it's a pollutant in the air, and there's two main causes of CO pollution in the air. One is burning of cars or burning of engines, burning of fossil fuels, and two is natural burns, for example, forest fires and the like. So, interestingly enough, there's a major CO over the Congo, the DRC. There's big forest fires, but also big mine activity happening around here, and we also know what's happening in India and China. So that's a particular image of that's between 1919 and 2019. But we want to compare now a, 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 image that is pre-COVID with the image that's during COVID to see the impact of COVID regarding the CO levels in the atmosphere. Most notably, the argument is because there's COVID, there's less economic activity, less combustion of or burning of fossil fuels, produce cars and oil and all these sort of things. So therefore, the CO2 levels in the atmosphere should have been less. So we want to generate a second image, and the two we want to compare. So we can do the same. We're going to basically copy and paste the first part of the code. So I'm going to generate a second image, or I'm going to create a second variable. Okay, so I'm going to call the collection pre, meaning pre-COVID, and I'm going to remember this starts from 2018-11, so I'm going to make it 2019, the first month till the second month, till the end of the second month, after 6 months. So that's make it the first of the 20th, after the 1st of January till the end of June. That's my pre-COVID image. Then again, I'm going to do a collection. Let's call it collection COVID. And I'm going to do this in 2021 and 21. I'm going to keep my months and my my days exactly the same. So I've got now two variables. I've created a pre-COVID variable and I've created a COVID variable. I'm going to present the visualization of the two images is exactly the same. The map center is exactly the same. So what I'm going to do now is I'm going to add another layer. Remember, I've generated the second image now, and I want to add that image as well. Remember, I'm going to create a collection pre, and I've created a collection COVID. And the rest I keep the same. I can change the name for it. So CO, I'm just going to say pre, and I'm going to name this one CO COVID. COVID. And let's just have a look and see they all look fine. So I'm just going to run this code. I should get two images now in this layer. Yes, there's my CO pre and there's my CO COVID images. Remember, I'm now calculating in both cases the mean images. Now that the layers have been created, we can interrogate them a little bit more. So if we toggle both, you'll see there's the image. Let's untoggle that one. That's the pre-COVID image of CO2 in the atmosphere. And that is our post during COVID image of CO2 levels in the atmosphere. On first glance, if we toggle to, there seems to be some difference, but in the main, not that much. But this is an image, it's a high level image. So as I say, the details are in the when we zoom in. So let's take, for example, the inspector. Take a general point. Let's take this point, for example. We left click on it and it's going to recreate the necessary statistics. So you'll see um, that pre-COVID, the level was 0.0510 and during COVID, 0.56. So the value is actually more during the COVID than pre-COVID. Let's try a different place and let's click on that specific location to see the values there. And again, very similar, the column density um, pre-COVID and post-COVID. Let's take this value, for example, over the ocean. Let's see. And here we say the before COVID 0.0238, during COVID 0.0236. So substantially less here. So just from looking at these three areas, it's evident that some areas did experience an increase in CO2 levels during COVID than compared to pre-COVID, while some other areas recorded decreases in the CO levels. It all depends on the specific location itself. We can obviously um, zoom into your specific region of interest um, and do exactly the same analysis for your specific region of interest, looking at um, the CO2 levels pre-COVID and the CO2 levels during COVID in your specific location. Now that you've scrolled down, we can use the inspector function again. Let's just make sure that we are just make your two layers more transparent. And I'm going to click on my region of interest and it's going to generate the necessary statistics. So the level of CO, remember the level of CO is molecules per square meter. In my area, pre-COVID was 0.021 and during COVID was 0.0212. So that's actually a decrease in the CO2 levels from pre to during COVID in my specific region. So remember, you can increase or decrease the transparency. You can select the layers. You can compare the layers that you want to display. And remember, you can also change the dates. Remember, and also, yeah, so you can change also the dates. We're going to continue with this specific data set in the next tutorial. Many thanks for watching. Stay tuned for more remote sensing tutorials.